we're on to our final theorem, which is the consensus theorem. Now, the consensus theorem is one that's a little bit more difficult to see when you identify trying to do reduction. And that reduction is going to be because it uses multiple numbers of terms. It's no longer just an x and a y. It's going to have an x and a y and a z. And the combination of the different pieces can make it a little bit tough to identify early on. But as you do a few more examples, it should become a little bit easier to understand. All right, let's start by showing out what the theorem is, and then we'll show the proof of how this works so you can get an idea of how it's actually going to be used. All right, the consensus theorem is xy plus x bar z plus yz is equal to xy plus x bar z. So you can see what we will be doing is removing this yz term. And that's why I say it's a little bit more difficult to see because a whole term gets taken out without any knowledge of it sharing something as simple as like x and an x bar. Okay, so let's do the proof of this so we can kind of see how is it that this gets reduced. All right, so let's just write down what it is that we want. Xy, x bar z plus yz. All right, so the first thing we need to do when we're trying to make a reduction is to make a reduction, it's going to be easier for us if all terms share something in common. And right now we have, okay, everything has, the first two have something in common, an x and an x bar. The first and the last have something in common, that's x and a y. And then the two last terms have something in common, but nothing in common between all three. So let's try to fix that. So what we're going to want to do is try to add x into the term. So how we're going to add x into the term is we'll say, what I want to do is say, let's add just a 1 so far. So I can say it's 1 ended with yz. So we can see that that's not changing the equation at all. And then I can say, you know what, 1 is the same as x plus x bar. And that's what we're going to do. We're going to try to substitute that piece in. So I get xy plus x bar z plus, in parentheses, x or x bar with yz. Okay, now that I have that, I am going to multiply that in. So I have xy plus x bar z plus x yz plus x bar yz. So now instead of 3 terms, I have 4 terms, and now everything has an x in it. All right, the next thing I'm going to see is now I'm going to look for, do I have something that's in common? Well, if we look at this, I have an x and a y, and now I have another term that has x and a y together. So let's factor that out. So I have xy. The first one is 1 or z, and then we have 2 terms that just follow along. And if we look at this parentheses item, 1 plus z is just 1, and xy1 is just xy. So I just copied that down as xy. Then we'll do the next terms, which is x bar z or x bar yz. And again, I'm looking for something that's in common. I have an x bar and a z. So let me factor that piece out as well. So I'll have x bar z with 1 plus y. This 1 plus y ends up becoming a 1. And we'll have x bar z. So why did I say this is not the easiest theorem to identify? Because the identification is kind of would require you to add in extra terms. The extra term is identifying that, oh, if I put a 1 in here, and then that one I can expand out, that's going to lead me to have, smaller amount of terms. So the easiest way to do this is to just see if you can identify this consensus theorem right off the bat. So let's just review. Consensus is going to be in two forms. We have the sum of products form, the ands followed by ors. This is the one we just discussed. And then if we look at, if we were to done the duality of this, the other form would have been x or y, and it with x bar or z, and it with y or z is equal to x or y, x bar or z. All right, so let's do a little example here.